Here we're doing scientific method exit ticket answer key or solution. Over here on the right we have a graph that is volume versus pressure, and the units are liters versus pascals. And it's a nice clean 1 through 5 or 0 through 5 on each side. The graph has a title, volume versus pressure of a gas at constant temperature. Volume versus pressure, X versus Y, independent we control versus dependent you read out as a measurement observation. And it says constant temperature. Temperature is not anywhere here. And constant means it doesn't change, so that's why it's not depicted on the graph. So what I've asked you to do here is use RACE to answer this question about the graph. How does the pressure of a gas change when we increase its volume? So if we look at this and we start with 0 liters of gas, we don't even see a point on the y-axis. In fact, at that point, there is no 0 point for volume. So we assume it's very, very high up here somewhere. We can't be sure. When we add 1 liter of gas, then we have a pressure of 2 pascals. When we add 2 liters of gas, we have a pressure of 1 pascal. So we went down from 2 to 1. When we look at 3, so we're looking at data points now, okay? At 3 liters, we have less than 1, maybe more than half though. It looks like more than half of a liter. And when we have 4 liters of gas, we have about a half, and it seems to level there. But consistently, the answer would be a decrease. It went from 2 to 1 to maybe 0.75, 0.6, 0.5. Something like that is what I read. So what you're actually interpreting is data points at specific volumes. And of course, we don't have the tick marks here that indicate 1/2, 1.5, 2.5, 3.5, but you can imagine them, and you can see that 1.5 is in fact less pressure than it was at 1. So you're using every single part of the graph. This is not a trend line. This is actually a line that or a curve that fits the points. So that's really the only thing we're not utilizing here. So our answer is the pressure decreases, but we don't want to write the pressure decreases because we're trying to use RACE. So first we're going to restate the question. The question says, how does the pressure change when we increase volume? So let's start with when we increase volume. The pressure blank. That's a restated question. Even if you don't know the answer, you can get that far. And whenever I give you a RACE assignment, even if you don't know the answer, you can rephrase it for me. Leave a blank and you don't know the answer. Practicing restating is very important. It goes to our literacy skills. So when we increase the volume, as we already analyzed our graph, we decrease the pressure, making sure we're using good grammar here and that it matches. When we increase volume, the pressure decreases. So that's R and A in one sentence, done. Citing and explaining are the things students usually have a hard time with. So because I have plenty of time here to show you, I am going to highlight RACE. So I'm going to go black is R, and my answer I'm going to go red. Okay? When we increase volume, the pressure decreases. Now we got to do C. So I'm going to erase my period, and I'm going to write as indicated, or we don't have to use fancy word, as shown in the graph, and you give it a formal title, volume versus pressure of a gas. And you can include the rest of that or not. Period. So this part is C, citing. This is where you got that information from. So R, A, and C all in one sentence. Restating, just to sound like you have good English, you're a good communicator. Answering the question, it's the heart of the task. And then showing the reader where you got that information, proving that you used some information to back it up, or some resource, some reference. And then finally, explain. Now in science, like I told you, I like you to pick two, especially if you're interpreting a graph, pick 2 points. So I can pick here, this is a really nice clean point. At 1 liter, we have 2 pascals. And then it drops when I have 2 liters to 1 pascal. So that's exactly the data point I'm going to point out. So I could erase that period and write, as shown in the graph, where 1 liter of gas produces a pressure of 2 pascals. Or how about I do this? You can even do this. You can make one big sentence. I'm going to rewrite a sentence, so start a new sentence so we don't get into run-on territory. The volume, we don't want to start a sentence with 1, so how would I write this? How about when the volume of gas is 1 liter, the pressure is 2 pascals. But when the volume is increased to 2 liters, the pressure is 1 pascal. So you don't have to repeat yourself and say it decreases. You're just pointing out the data. You're showing the reader, here's one data point, here's the other data point, and this is how I based my answer. It's evidence that your answer is correct. So basically when you're doing RACE, you are proving to yourself and whomever is reading your work that you are right. And so if you don't know how to read the graph, then that's a problem, because then you can't answer the question and you can't use RACE. But this is a great example of using RACE and reading the graph. Certainly, if you have any questions or you have trouble doing either of those two things, please reach out to me. I'm happy to help. We definitely want to practice this throughout the entire year. So, you know, as soon as you have trouble, let me know. But I don't expect you to be really great at this right away either. We take it in baby steps, right? You will grow a whole lot through this year. And this is just the beginning.